Namaskar. Good morning to one and all present here. On behalf of PG Department of Physics, Fakir Mohan University, and on my own behalf, I, Dr. Vikram Naik, extend a warm and cordial welcome to you all to this auspicious celebration of National Space Day 2026. As we all know, on 23rd August 2023, India achieved a historic milestone with the successful soft landing of Chandrayaan-3 near the lunar pole. India has become the fourth nation in the world to land a spacecraft on the moon and the first to land near the South Pole. The outcome of this historic mission will benefit mankind in the years to come. To commemorate the historic landing of Chandrayaan-3 on the moon, National Space Day is celebrated every year on August 23. The theme of National Space Day 2026 is Towards VIKSIT BHARAT, Innovating, Collaborating and Aspiring to Global Space Leadership. Moving ahead, I feel extremely honored to welcome our distinguished guest. For today's function, we are privileged to have our beloved Vice Chancellor, Sri Santosh Kumar Tripathi as our Chief Guest and Sri Pramod Kumar Parida, retired Senior Scientist, Odisha Space Applications Center, Bhubaneswar as our Chief Speaker. Among other esteemed dignitaries, we have our Chairman, PG Council, Professor Santosh Kumar Agrawala, Dr. Rajiv Vishwan, Assistant Professor of Physics, Mr. Himanshu Bhushan Naik, Assistant Professor of Physics. I now request all the dignitaries to kindly inaugurate the program by watering the holy plant and then take their seats on the dais. Before we proceed further, let us rise to show our respect and pride for our university by standing for the university anthem. I request the technical people to kindly play the anthem. Thank you. As per the rich tradition of our university, I request our student volunteers to welcome our esteemed guests by presenting them with saplings as a token of gratitude and commitment to sustainability. Now I request the beloved Vice Chancellor sir for presenting about the meeting. Thank you, sir. Now I would like to invite Dr. Rajiv Biswal sir to kindly introduce our distinguished guest.
समस्तଙ୍କୁ ମୋର ନମସ୍କାର। Esteemed Sri Santosh Kumar Tripathi, Sir, Vice Chancellor, Fakir Mohan University, Chief Guest of this occasion, esteemed Chief Speaker, Mr. Pramod Kumar Korida, former Senior Scientist, Orissa Space Application Center, Bhubaneswar, esteemed Professor Santosh Kumar Agrawal, Sir, Chairman PG Council, Fakir Mohan University, guest of honor of this occasion, esteemed Vivekananda sir, Himanshu sir, respected all the faculty members, research scholars, students, media persons, and my dear participants. It gives me immense pleasure to welcome you all in this National Space Day program organized by Department of Physics, Fakir Mohan University on this occasion of National Space Day. This year, program is being organized around the inspiring theme towards VIKSIT BHARAT, innovating, collaborating, and aspiring to global space leadership. The theme beautifully reflects India's growing achievement in space science and technology. It is my honor to introduce our distinguished guests. We are especially privileged to have our beloved Vice Chancellor, Sir, Sri Santosh Kumar Tripathi. Sir, under your leadership, the university continues towards achieving academic excellence, research innovations, and scientific advancement. Your presence at this National Space Day program is a source of encouragement to our students and young researchers. It is also my privilege to introduce our distinguished Chief Speaker, Mr. Pramod Kumar Korida, former Senior Scientist, Orissa Space Application Center, Bhubaneswar. Mr. Korida has over 35 years of experience in geospatial technology, remote sensing, GIS, photogrammetry, space-based applications. He holds a master's degree in oceanography with first class pass and gold medalist from Barampur University and postgraduate diploma in space, remote sensing and GIS from Indian Institute of Remote Sensing, ISRO, Dehradun. During his distinguished career at Orissa Space Application Center, he contributed to several major national and state level projects involving remote sensing, satellite data, natural resource mapping, coastal and urban information system, agriculture, forestry, GIS, drone survey, AI and ML based geospatial solutions. Sir, we are truly honored to have you with us and we look forward to your valuable insights and experience in the field of space technology. We are honored to have with us Professor Santosh Kumar Agrawal sir, Chairman PG Council, Fakir Mohan University, as our guest of honor. Professor Agrawal is a professor and head Department of Physics. He is a pioneer physicist in the area of nuclear physics and nuclear medicines. He has been providing valuable academic leadership and guidance to the postgraduate academic activities of the university. Sir, your presence today adds a great significance to this program. On behalf of the Department of Physics, Fakir Mohan University, again I extend my heartfelt welcome and gratitude all our distinguished guests. National Space Day is an opportunity to inspire our next generation to dream beyond boundaries, exploring unknowns, and contribute to the scientific and technological development of our nation. With these words, I extend a very warm welcome to everyone on the dais and off the dais and wish the National Space Day program a great success. Thank you.
Thank you, Rajiv sir. Next, I request the technical team for screening of short video on National Space Day.
Namaskar. 23rd August 2023 is a historical day for India as our Chandrayaan-3 successfully soft landed near South Pole of Moon, and India is the first country accomplished this important mission. This day is announced as National Space Day by our Honorable Prime Minister of India, Sri Narendra Modi.
जब भारत ने चंद्रमा पर तिरंगा फहराया, उस दिन को अब हिंदुस्तान नेशनल स्पेस डे के रूप में मनाया जाएगा।
As India prepares for the National Space Day 2026, I am delighted that this year the program is organized in Ahmedabad, which is closely linked with Dr. Vikram Sarabhai.
In my opinion, the aspect of space research, which I would like to stress most, is in relation to the national capability, the self-confidence that this will generate.
And the birth of India's space program. This year's theme towards VIKSIT Bharat, innovating, collaborating, and aspiring to global space leadership gives us both the direction and responsibility. Innovation must serve our people. Collaboration must unite ISRO, industry, academia, startups, and global partners. Leadership must rest on scientific excellence, self-reliance, and peaceful use of space. India is entering into an exciting era in various domains, including Earth observation, communication, navigation, human spaceflight, and planet exploration. I invite the students, researchers, academia people, and industry partners and other citizens of our country to join in this celebration. May this celebration inspire the young minds of India to imagine boldly and build a developed, confident, and globally respected India. Jai Hind.
शुरुआती दिनों में जब इसरो ने अपना पहला रॉकेट लॉन्च किया तो उसके पार्ट्स को रिसोर्सेज की कमी के कारण साइकिल और बुलक कार्ट पर ले जाया गया।
तो जब नासा से ये नाइके अपाची रॉकेट आया तो इसे कंटेनर से बाहर निकाला गया और फिर बैलगाड़ी पर लादकर असेंबली बे से लॉन्च पैड तक लाया गया। इसके लिए जिस पेलोड की हमें जरूरत थी वो भी ज्यादा बड़ा नहीं था, तो हमने साइकिल का इस्तेमाल किया।
वही आज इंडिया ने सक्सेसफुली मून पर लैंड कर लिया है। क्या ये साइकिल से चांद तक का सफर इतना आसान था? तो आज की इस वीडियो में हम बात करेंगे इंडियन स्पेस रिसर्च ऑर्गेनाइजेशन इसरो के बारे में। अक्टूबर 1957 को सोवियत यूनियन द्वारा इतिहास रचा गया। इस दिन सोवियत यूनियन ने दुनिया की पहली सैटेलाइट को लॉन्च किया। उसके एक महीने बाद 3 नवंबर 1957 को सोवियत यूनियन ने स्पुतनिक 2 लॉन्च करी, लेकिन इस टाइम पहली बार किसी लिविंग क्रीचर को धरती से बाहर भेजा गया और ये लिविंग क्रीचर एक फीमेल स्ट्रीट डॉग थी जिसका नाम लाइका था। इसके बाद इंडियन साइंटिस्ट डॉक्टर विक्रम साराभाई ने रियलाइज किया कि इंडिया को अगर आगे बढ़ाना है तो हमें भी स्पेस में डेवलपमेंट करना जरूरी है। तब जाकर 23 फरवरी 1962 को इसरो की शुरुआत होती है। शुरुआती दिनों में इसरो का नाम इंकोस्पार यानी इंडियन नेशनल कमिटी फॉर स्पेस रिसर्च था। इंकोस्पार को डिपार्टमेंट ऑफ एटॉमिक एनर्जी के अंडर रखा गया। उस समय के इंडियन प्राइम मिनिस्टर जवाहरलाल नेहरू जी ने डॉक्टर विक्रम साराभाई को इंकोस्पार की कमान सौंपी और इन्हें इंकोस्पार का चेयरमैन बनाया गया। इसी वजह से आज उन्हें फादर ऑफ इंडियन स्पेस प्रोग्राम कहा जाता है। पहली रिक्रूटमेंट में जिस किसी ने भी इंकोस्पार को ज्वाइन किया उनको ट्रेनिंग के लिए नासा भेजा गया, क्योंकि उस समय पर इंडिया का खुद का कोई ट्रेनिंग प्रोग्राम नहीं था। इंडियंस को ट्रेनिंग के लिए नासा भेजने के लिए इंडिया और नासा के बीच कोलैबोरेशन हुआ, जिसमें नासा ने इंडिया को रॉकेट भी सप्लाई किया।
तो नासा ने इस कनेक्शन और डॉक्टर साराभाई द्वारा किए गए कोलैबोरेशन के जरिए साउंडिंग रॉकेट भेजा
और इस रॉकेट को लॉन्च करने के लिए जगह ढूंढी गई। केरला के थुम्बा गांव में रिसोर्सेज की कमी के कारण इसी गांव के चर्च में लॉन्च स्टेशन बनाया गया और रॉकेट के पार्ट्स को लॉन्च साइट तक पहुंचाने के लिए साइकिल और बुलक कार्ट का इस्तेमाल किया गया और फिर 21 नवंबर 1963 को इंडिया के द्वारा ये रॉकेट सक्सेसफुली लॉन्च किया गया और ये था इंडिया का लॉन्च किया गया पहला रॉकेट और ये एक साउंडिंग रॉकेट था। उसके बाद जाकर इंडिया ने अपना खुद का साउंडिंग रॉकेट बनाया जिसका नाम रोहिणी 75 रखा गया और इस रॉकेट को 20 नवंबर 1967 को सक्सेसफुली लॉन्च किया गया। उसके 2 साल बाद 15 अगस्त 1969 को इनकोस्पार को रिनेम करके इसरो कर दिया जाता है। 30 दिसंबर 1971 को विक्रम साराभाई की मृत्यु हो जाती है जिसके बाद 1972 में एरोस्पेस साइंटिस्ट सतीश धवन को इसरो का अगला चेयरमैन बनाया जाता है। आगे चलकर 1975 में इसरो ने अपनी पहली सैटेलाइट लॉन्च करी जिसका नाम आर्यभट्ट रखा जाता है और इस सैटेलाइट को सोवियत यूनियन के रॉकेट से लॉन्च किया जाता है। अप्रैल 1984 को इंडियन एरोस्पेस की हिस्ट्री में एक इतिहास रचा जाता है। 3 अप्रैल 1984 को राकेश शर्मा स्पेस में जाने वाले पहले इंडियन बनते हैं। ये सोवियत यूनियन के रॉकेट सोयुज T-11 में स्पेस में जाते हैं। धीरे धीरे इसरो की ग्रोथ बढ़ने लगती है। ईयर 2008 में इंडिया अपना पहला मून मिशन करता है। पहला मून मिशन चंद्रयान 1 से किया था और इसने मून पर हार्ड लैंडिंग करी थी। साल 2013 में इसरो अपना पहला सक्सेसफुली मार्स मिशन करता है और इंडिया पहली कंट्री बन जाती है अपने पहले ही अटेम्प्ट में सक्सेसफुली मिशन मार्स करने वाली और दुनिया का चौथा देश बनता है जो मार्स के ऑर्बिट में एंटर करता है। 22 जुलाई 2019 को इसरो अपना दूसरा मून मिशन चंद्रयान 2 करता है। चंद्रयान 2 मून पर सॉफ्ट लैंडिंग के लिए निकला था लेकिन मून पर लैंडिंग करने से केवल आधे किलोमीटर पहले सॉफ्टवेयर ग्लिच के कारण से इसरो का चंद्रयान 2 से कनेक्शन टूट जाता है और चंद्रयान 2 मून पर क्रैश लैंडिंग कर देता है। आज 4 साल बाद 14 जुलाई 2023 को इंडिया अपना तीसरा चंद्रयान मिशन चंद्रयान 3 सक्सेसफुली लॉन्च करता है और चंद्रयान 3 23 अगस्त को मून पर सक्सेसफुली सॉफ्ट लैंडिंग करता है और इंडिया दुनिया की चौथी कंट्री बनती है मून पर सक्सेसफुली सॉफ्ट लैंडिंग करने वाली। चंद्रयान 3 मून के साउथ पोल पर लैंड करता है जिस कारण से इंडिया दुनिया की पहली कंट्री बनती है जो मून के साउथ पोल पर सक्सेसफुली सॉफ्ट लैंडिंग करती है। इसी वजह से अब 23 अगस्त को नेशनल स्पेस डे के रूप में मनाया जाएगा। इंडिया ने अपने पहले रॉकेट लॉन्च में साइकिल और बुलक कार्ट पर रॉकेट के पार्ट्स का ट्रांसपोर्ट किया था और आज इंडिया दुनिया का पहला देश बन गया है जो मून के साउथ पोल पर पहुंचा हो। साइकिल पर रॉकेट के पार्ट्स ले जाने से लेकर सक्सेसफुली मून मिशन करने का ये सफर काफी लंबा था जिसमें देश को कई सारी चुनौतियों का सामना भी करना पड़ा। ये सब कुछ आज इसरो के महान साइंटिस्ट के बदौलत पॉसिबल।
Now I would like to invite Professor Santosh Kumar Agarwal, Chairman PG Council, for his address.
Very good afternoon to all. Esteemed Vice Chancellor, Sri Santosh Kumar Agarwal, sir. Today's chief guest, esteemed Chief Speaker, Mr. Pramod Kumar Parida, sir, retired senior scientist, Odisha Space Application Center. Respected coordinator of the Physics Department and Atmospheric Science, Dr. Vivekananda Naik, Dr. Rajiv Vishwa, Mr. Himanshu Naik, Dr. Samar Bose, Mr. Suraj Pati, and all my dear colleagues and my beloved students and media friends. A very warm welcome to the celebration of National Space Day. We are celebrating this day because all of you just now seen the video, because this day India has created a history. As you know, space is no longer a distant dream. I can say space is our future and India is leading that future. So in 2026, I can say we are preparing for Gaganyaan, India's first human space flight mission, and Sukrayan mission to Venus. And why this day we are celebrating, I can say this is for our inspiration because we are very close to Chandipur and Wheeler Iceland, where India's missile history was written. We are sitting at the gateway of India's space and defense research. Second one is for opportunity. Space is not just for rocket scientists. As you know, now it means AI, data science, remote sensing, agriculture, disaster management, climate studies, geopolitics. So that is why the room is totally full of students. Then next one is this is for our national pride also. We are here to celebrate the national pride. At this outset, I extend my sincere gratitude to all the dignitaries on the dais, starting from the chief guest and our research person who has consented to share his knowledge and experience to this gathering. I would also like to thank the department, all the faculty members, students of the Department of Physics as well as the Department of Atmospheric Science for organizing this day for us. So thank you all. Thank you.
Thank you, sir, for your inspiring words. It is now my privilege to invite our beloved Vice Chancellor, sir, to felicitate our chief speaker, Sir Pramod Kumar Koida, sir, with a token of appreciation. Chief speaker, Sir Pramod Kumar Koida, sir, to address the gathering.
Respected Vice Chairman, sir, Dean, Head of the Departments, esteemed professors, and my dear students. First of all, I express my heartfelt deep gratitude to Fakir Mohan University for inviting me on this historic occasion. We are celebrating, this is the third National Space Day. As you know, on 23rd August 2023, we have already seen the video. At 4 p.m., India created history and Chandrayaan 3's Vikram lander made a soft landing near the south pole of the moon, and India became the first nation to do this historic feat, and it is the fourth nation to able to land on the moon. So on this historic occasion, Honorable Prime Minister of India declared this day as the National Space Day. Friends, we are celebrating it as today at Fakir Mohan University. This university is named after great Odia poet Vyasakavi Fakir Mohan Senapati. Fakir Mohan taught us to dream in our own language, to be self-reliant, and to see the future while rooted in this soil. What is the space program that we have seen? The journey. It started from a small church that you have seen in Tumba, Kerala state, to the south pole, to the moon. So that is the journey of Atmanirbhar Bharat. This year celebration is a very special celebration as announced by Dr. V. Narayan, our ISRO chairman. Our national celebration is being held in Ahmedabad, the city of Dr. Vikram Sarabhai, the pioneer of Indian space science. And our theme is what's VIKSIT BHARAT. Innovating, collaborating, and aspiring to become the leader in space technology. India is no longer just launching rockets. Today, we are preparing the Gaganyaan for our human space flight mission. We have built a NISA, NASA and ISRO synthetic aperture radar. It is already now in the orbit. And it has a S and L band, a microwave band, which will be available free. The data will be available free all over the world for researchers, scientists, for everyone. To actually the data is already the NISA has already started to send pixelize the L and S band. And it is the most expensive satellite. And this data will be available for all to study. And we have 300 plus startups. Those are building rockets, satellites privately. And very soon, as the Honorable PM said, India will have its own space stations. From Aryabhatta in 1975 to Chandrayaan 2026 or to Gaganyaan 2026. It is a 50 years journey. In this 50 years, we have touched lives and touched also moon. My dear students, space is not far from you. We are at the gateway of space station, that is at the Wheeler Island. We have a launch station near to you. Our coastal vulnerability, our cyclone studies, our paddy crop estimation study, Chilka and wetland studies, all these studies we use satellite data. For this, we need to study physics. We need to know the blackbody radiation, what are the different electromagnetic spectrums are there, and how these spectrums are utilized to build the sensors. So that we have to, because we are actually here, we are studying also this in physics, and we are also devising a lot of algorithms in mathematics and using geography, all whatever we are doing, people like us, they are in ISRO, in NASA. Okay. So space technology is not only for ISRO. The people like geologists, physics, mathematicians, computer scientists, storytellers, entrepreneurs, they built up ISRO and NASA. The next Chandrayaan, the components, maybe one of you may develop the component of Chandrayaan and Gaganyaan. So you bring for that. So with this, I would like to begin my presentation. Today, I have named it Curiosity to Cosmos. So, as I have already told, August 23 marks the dawn of India's lunar south pole mastery. The observation India commemorate National Space Day annually on August 23 to honor the historic landing of Chandrayaan 3 in 2020. The milestone, India became the first nation in human history to land near the lunar south pole and the fourth nation globally to achieve a successful soft landing. The mission to inspire next generation of researchers towards science, technology, engineering, and innovation by demonstrating that extreme orbital challenges that can overcome through precise engineering. So this is Chandrayaan 3, the historic landing on the moon's polar region, 23 August 2023. The first nation to land, fourth nation in the globe. Vikram lander and Pragyan rover put their feet on moon surface. Scientific quest, we have also taken samples, studying lunar soil, mineralogy, seismic activity, and more. Let us know about that 15-minute lunar gauntlet. What really is the difficult phase? That means it will shift from a Earth orbit to a moon orbit, and again it will land on the surface of the moon. So that means that orbital speed is about 1.6 km per second to 2 meter per second. You see, that means the reduction of 99.9% velocity reduction that should happen. atmosphere braking versus power descent. As you know, in our Earth atmosphere, about 100 kilometers from the surface of the Earth, where we have frictions. So that any is of course a body you want to bring it to Earth, we deploy a parachute, we deploy a rocket to reduce its velocity. But in the moon surface, we don't have an atmosphere and we don't have a actual 1/6 of the gravity is there, and so we don't have atmosphere. So what should we do? From 1.6 kilometer per second, we have to bring it to 2 meter per second. So we have to use the anti-thrust mechanism. That means you know the physics. That means we have to precise engine control, strict fuel, because we don't have much more fuel in it also. We have a limited fuel. We have to use that fuel to, or in opposite direction, to check the speed and reduce the speed from 1.6 kilometer to 2 meter per second. So that means there is a horizontal component of a velocity, there is a vertical component of a velocity which is 1.62 meter per second square, and we have to we use our fuel efficiently to reduce the use of the fuel that is available on board and make the velocity to 2 meters per second to have a soft landing. And another thing, that there is a 2.6 second round, that means time lag. In between moon and Earth, there is a 1.3 second time lag. That means once you send a message, you receive the message at a 2 point, that is twice the time. There is a 2.6 second, that is the time gap is there. So what scientists will do? Scientists will operate deep signals at the laboratory, sitting at the laboratory, maybe at the Bangalore, at the ISRO center, the ISRO headquarters. And that signal or instruction will reach at the moon vehicle at around 2.6 seconds. So that is the difficult, the human blind spot is there. So within that you have to control your your vehicle. Okay. So that is the mission. That means we have a limitation of fuel. We have a limitations of all these throttling mechanism. So we have to make all these adjustments to make. So that's why we made failure at the first attempt when we actually tried to reach at the moon, but we could do at Chandrayaan-3. Okay. So the unknown terrain variables are also there. So moon surface is not, as you see, it is a plain surface. There are deep craters are there, steep slopes are there, boulders are there, and the plains are there. That means the lander, it will take pictures all the time, and it is having the onboard computer system is there. It will use its own UI, AI to process the images subsequently and decide which part of the area it will able to land. And it should be a plain area. It should not fall in a hole, so that it will have a soft landing. So all these things happening on board. Okay. So now India could do it, and it could land at a south pole of the moon, which only one country, India, could do it. No other country attempted at the south pole. Okay. So Chandrayaan-3 power descent braking orbit, we see it was something like from 1.6 kilometer per hour to 2 meter per second. That means from speed, how it is reduced by using one rocket its fuel. Because there is nothing is there, because atmosphere is not there and gravity pull is there. To check all these things, we have to make a soft landing. Okay. That means master technology, what actually India has achieved, the precision throttle propulsion, it has achieved real-time terrain assessment. And again, we have to study about autonomous guidance and navigation, because that is one science that we have to master, and we have to also master hazard avoidance. That we have to master. And I think by the time period, the scientists have all developed the actual science to do that. So, who are the visionaries built up this Indian Space Science, Dr. Vikram Sarabhai, the founder architect, Dr. Satish Dhawan, the system builder, Dr. APJ Abdul Kalam, the launch vehicle pioneer, Dr. U.R. Rao, the satellite visionary, Dr. K. Kaustubhanga, the planetary explorer, Dr. K. Sivan, the moon surveyor, Dr. A. Somanath, the architect of the new frontier, and presently Dr. B. Narayan is the present ISRO chairman. If we look at our history, Indian mission compared to the world milestone, you see that we started at 1975, Aryabhatta is our first launch, or whatever we have seen in the video also. But the world started 1903, Wright brothers. Okay? So, if you see now today, we are at the journey 2026, 2023, we have completed Chandrayaan. Now, Aditya L1 also we have completed, 2026 we are planning, Gaganyaan we are planning. ISRO redefined global space exploration through extreme cost efficiency. If we have a comparison matrix of global agencies versus ISRO, we will see that the cost to orbit, they spend high billions, immense capital expenditure for launch. But we achieved a very fractional cost, achieved through frugal engineering and modular design. Core philosophy of other countries or group like America and Russia, they want geospatial, they should have a dominance and a deep space exploration. But ours is the application driven. We have priorities like agriculture, weather, and communications as we don't want to be a global leader. Of course, now today after achieving this good, this research team is to aspire to be a global leader. But we tried with a very simple thought. Our application is, primary application is our agriculture, to study agriculture, weather, communication, that comes fast. Mars orbit intersection, multiple early historical failures before success. It doesn't mean that they have achieved success at their first attempt. They have also made the failures. So, Mangalyaan successful on the very first attempt. We made it on the first attempt, we made it a success story. Lunar South Pole mastery. Luna 25 encountered terminal failure during descent. Chandrayaan 3 executed historic flawless soft landing. Launch vehicles evolution dictates our physical access to the orbital frontier. We started with SLV, ASLV. PSLV is a satellite launch vehicle, augmented satellite launch vehicle, polar satellite launch vehicle, geostationary satellite launch vehicle. If we look at you see, we started from 150 kg, now we start 8,000 kg. Okay. If you look at one of the applications of the space science is remote sensing. Architecture operates as humanity ultimate eyes in the sky. That means now India is able to launch the satellites, remote sensing satellites, or we call polar satellite because its orbit around the Earth, around 800 to 900 kilometers. It takes a polar orbit. Okay. It has both active and passive sensors. Active sensors, the sensor and the energy source both are same. Because the sensor itself sends energy to the Earth surface and it also receives the energy back in the receiving mode. But passive sensor uses sun as the source of the energy, and by using the black body radiation concept, so whatever it reflects, it receives and the image is being taken. So if we look at the fundamentals of remote sensing, it starts with the sun through black body radiation that whatever we read it every day in the physics. Okay. So some of the governing laws, as you know, the Planck's radiation law. I don't know in my past interview when I appeared as a actual of course I am also a physics student. It is asked by one of my interviewer to derive the Planck's radiation law. He gave me a chalk and a blackboard. He asked me to derive and explain how it relates to remote sensing. So that is why. You see, when a body is heated, as in temperature grows, its maximum wavelength, that means at which wavelength it radiates more energy or it emits more energy, it shifts towards low wavelength. Okay. So sun is the outer surface, something about 6,000 degree Kelvin, the outer surface temperature. It radiates maximum or emits maximum temperature at around something green, which is something 5.5 or 4.5 actual micrometer. Okay. So these are some of the governing laws that you already know because these are basic fundamental laws that is being used for remote sensing. Okay. So we receive panchromatic image, means black and white image. We receive also multispectral image, that means we overlap the images at different bands and we create natural color as well as false color images. The hyperspectral imaging concept is there because this is the challenge where the bandwidth is very small, the hyperspectral, where the multispectral the bandwidth is large. Also, there is now we are using also LIDAR, which is active optical remote sensing. Okay, and the data, the science we are using for studying the Earth's surface. So, the satellite telemetry actively manages our terrestrial and oceanic ecosystem. We see the terrestrial application where you see our Earth like this. We can see the green, the green, you see directly you see the geometry of the plots where you can see what we have, whether we have grown any type of crop. Once you study this, the signal, how the colors relates to different reflectors, then you can study what is the actually acreage of what type of crop that is grown. And we can study also oceanographic different applications, what are the actual phytoplanktons grown and what are the different temperature regions that you can study for the oceanography. Okay. The electromagnetic spectrum detects how we stream data from orbit. That means if we study about the micro portion of the electromagnetic radiation, as you know, L and S band, NISA has L and S bands. These are different bands, L and S band, C band, Q band, K band. These are the bands of the electromagnetic regions we utilize for remote sensing purpose. Okay. We will see the micro remote sensing. What are the bands? L, S, C, X, Q, K. These are different wavelengths where it operates. And what are the difference between the micro and optical remote sensing? Optical remote sensing, it has the limitations. It cannot work in the cloudy because you know the wavelength wherever it gets reflected from the top of the atmosphere from the cloud. So during the cloud during the rainy season, optical remote sensing is not used. Then how can we monitor fraud? How can we monitor this type of disasters? In that case, we will use microwave remote sensing. Where the microwave object, it can pass the cloud because it has a long wavelength. The cloud will not be obstruction for it. So the microwave remote sensing for studying these natural disasters it will be useful. Microwave remote sensing, it has two types of it is a slant, that means side-looking airborne radar. Another is synthetic aperture radar. Side-looking airborne radar where it uses a physical antenna, and synthetic aperture radar it uses a small antenna and it is synthesizes at different exposure stations. Whatever the backscatter it receives, it is synthesized through the programming and as if it is receiving from a long antenna. So it is why it is side-looking, why it is not looking perpendicular? Because if it look perpendicular a radar, the backscatter look at a different objects, it will reach the backscatter at the same time. It will not be able to distinguish from one object to other object. That's why it is placed at a side-looking angle. That means whenever it sees object because it mostly it ranges. That means it receives the backscatter and mostly it measures the time and it uses the electromagnetic speed of the light to range the distance of the different objects. From that, it takes the image. It has two types of resolution. One is range resolution, another is azimuth resolution. Whereas the optical remote sensing, it has one resolution. It is a square. Whatever it sees, it is a square. But in micro remote sensing, it is a rectangle. Here azimuth and range, they are both different. Okay. So the applications are different, as you know, during the plot time, micro data is used. And now we don't have to look at foreign satellites. We have RISAT, now we have NISAT. You can get the data freely. If you can go to ISRO sites, you can download your data for the study area, whatever somebody is interested for some micro remote sensing. One study, you should have a very strong physics and mathematics knowledge to understand. Because the remote sensing, whatever the optical remote sensing data you see of digital number, image is not a digital number matrix. It is a matrix of digital number. That number, that means the energy converted to a number due to analog to digital converter. That number, you have to interpret what is that number. That number is the reflectance from a tree, the reflectance from a urban body, from water, what it is. So you have to use different algorithms to interpret the number. But here, in the microwave, that is not a number. It is a complex number, A plus IB. That means the complex part number is, one part is amplitude, the echo strength, other part is the phase. The phase and amplitude. Two parts. Mostly the physics and mathematics students, they will understand what is. So the interesting part is that you have to understand, using the programming, you have to separate the amplitude part, you have to separate the phase part of that. So that is the actually problem and the complexity. That's why most of the people, the very few micro scientists are there. So they should be very good at physics and mathematics. Otherwise, it is difficult to interpret the microwave part of the remote sensing. So, then I talked about microwave. I am talking now the sonar. It is, you see, sound navigation and ranging. It is interesting, you see. The sonar is used to map the topography of the ocean surface. The topography, you see, the Chilka Lake. How do you set that? Because every year, you see, Chilka is getting, you see, the depth is reduced because of the deposit of the river sands. Okay. That's why you see, now it is something 900 square, times it was something 1100 square kilometers it was there. Okay. So now it is getting, you see, because of the riverine mud and sand, it is getting deposited. So it needs to be studied. Your Chilka Lake, the lake topography or lake bathymetry needs to be studied. Whether it needs that somewhere, it needs to be actually examined so that the Chilka Lake can be remain a sustainable ecosystem. Okay. So for that, if you manually it is impossible to use a boat and earlier you are using some way to measure at a sampling station and create the bathymetry. But nowadays this is very actually a rudimentary method. Now we are using the sonar actually to make the bathymetry study of the different ocean surface, lake, the reservoir also, like Viracocha reservoir also, sonar is used. So that is also physics. You have to understand how the sonar works. Okay. Now the global GNSS, global navigation satellite systems, represent the individual unit of modern life. That means the GNSS system is used for the GPS purpose, global positioning system. If you want to know the latitude, longitude at any location, you need to know about the GNSS. And India is having a GNSS for the NAVIC. We have something 7 satellites for this purpose because it is a regional navigation satellite. It is not a global navigation satellite system. But the country like Russia, and country like USA, they have a global navigation because it requires for a GNSS and RNSS. It requires more satellites to at space. Something 24 satellites needs to be at any place to be a global navigation satellite system. Okay. The regional navigation satellite system from 4 to 5 or 7 satellites required. So system GPS is a global positioning system is named for the USA. GLONASS is for Russia. Ours is NAVIC, India. It is a geostationary satellites and this is used for measuring the latitude, longitude for any place at the surface of the earth. So this is napping. We have something like 4 satellites in geosynchronous orbit and something 3 satellites at polar orbit. Geosynchronous orbit, these orbits are parallel to equator. They are from west to east. Okay, the heights are something like 36,000 kilometers above the surface of the earth. Where the polar orbits, they are at something like 800 to 900 kilometers and they are mostly around North Pole to South Pole. These are polar and geosynchronous orbit. Okay. Space constitutes the ultimate high ground for national defense. Now you say. Secure navigation. One is navigation. Then maritime domain awareness. Securing the Indian Ocean, regional and tracking naval fleet movement via satellite telemetry. Recognition, survey and surveillance. Continuous border monitoring and terrain mapping and real time. You see, nowadays for the defense, it is not that only the soldiers will move around the border and look at how the border is trespassed or not. No. Nowadays, India is employing some of the satellites which are only for defense purpose. Continuously, the images are being taken and it's being analyzed and being seen that whether any part of the country where the border is there, whether some trespassing occurs or not. Okay. Now, that is for the use of this remote sensing. It is not used for civilian purpose. It is used for mostly defense purpose only. Institutional catalysts are driving India's commercial space evolution. Private nowadays, you see, after our Prime Minister Narendra Modi. Okay, now the private corporations, companies, they are now launchpad. They have the launchpads and startups. So now there are a lot of in India also. There are some private companies. They are planning to launch the satellites. Okay, it is not now limited to ISRO. Satellite manufacturing hub also now. India is also satellite manufacturing hub. We are able to now. You see now the first Aryabhatta by the help of United States of Russia, we have launched Aryabhatta. Now we are in a position to help other countries to keep their satellites at the orbits. Now we have achieved that peak. Okay, remote sensing service we are using for our own agriculture, disaster management, immediate resolutions. There are high resolution there. There are global coverage is there for India. So now we have also capacity to analyze data. We have servers, we have AI, ML, algorithms we are using for automatic application for processing the data. We have achieved a paradigm shift. The transitioning from state-run monopolies to the new space ecosystem, resulting in explosion of a private space startups, satellite internet deployment, and modular satellite manufacturing. There are some of the companies there. They are now manufacturing different parts of the satellites now in India. We have now InSpace and NSIL. InSpace looks after the private part. It's a regulatory body of ISRO, and the NSIL it is for the commercial purpose, for the government purpose. Okay. Emerging technology are fundamental altering orbital mechanics. Now we have AI and machine learning processing massive hyperspectral data sets. Because hyperspectral something like there are 200, 300 bands, which is something like 10 nanometer weight. They are taking that is. Why this? We are reducing the electromagnetic band. We are reducing because we want to identify a particular object. If you have a wide spectrum, because the response that will be mixed. If you have a low spectrum, you can identify, okay, this is fatty, this is weight, this is something rubby, black ground, white ground. So if you have a proper spectral signature ground truth, that means if you have a radiometer and you collect the data and you identify, you create a spectral library and you use that spectral library and use the hyperspectral data, you can classify with a 99% accuracy what type of crowd it is or what type of object it is. Even depends. They can study that is it a tank or is it what? Whatever camouflage you made, whatever you cover, but it is made up of a specific object. It has a material property. That needs to be studied using a particular narrow band. Okay. Quantum communication. Enable unhackable secure data transmission. you see that is the computer science. You should do the encryption so that other people cannot decrypt it. The signal encryption is most important because you see, you are sending some signal and someone will intercept it and you know what is our secret. So now encryption, quantum computation is another science to study. Digital twin, very interesting. That means it is you are creating a replica. Suppose you want to create a digital twin of Fakir Mohan University. You have to use different multispectral data and you have to create a digital, digital replica of this. Okay, so that is called digital twin. Digital replica. How you can simulating that you have to use simulating launch vehicle, satellite behavior in virtual environment before digital testing. And before launching, if we can create a digital twin of launching, so we can know what are the failures, what are the limitations, and what are the actually we will be testing, and what solution we will be proposing. So now that is that in science we are not. That means knowing the uncertainties now. That is not the science here. We are simulating the problem and knowing the solutions. So that is the level of science we have reached. Hardware innovations. We have now space robotics, reusable rockets, small satellites, and CubeSats. Odisha's geographical position, if you see, makes it a very critical hub for special applications. The strategic importance, the proximate to Baleshwar to primary aerospace testing facility, embeds the region deeply in Indian defense and space applications. We have Wheeler Island where we are launching. That is the your Odisha, how it is actually in space evolution, how it helps the Indian space science. Okay, blue economy and fisheries. You know, I actually earlier when I was attending the international blue economy, there I have that Fakir Mohan University because I was invited as a being having emotions in something experience. I was also invited and I attended. I came to know that Fakir Mohan University is also named. You are also in that your position is great. You don't see that this is a unique university. Is actually in the national, you have a national footprint here. Okay, blue economy and fisheries, agriculture and mineral backing, places are monitored because we have a lot of mineral resources. So we should use space science, how to monitor, how precisely to identify different minerals and to explore and get the benefit out of that. Okay. Satellite intelligence powers Odisha's world-class zero casualty cycle management. We achieved this feat actually. You see that 1999 super cyclone, what casualties we have. Now you look at the stories after that, we have achieved zero casualty because we have used space science. We have monitored where the cyclone will hit our Indian Meteorological Department to achieve the position using space science. And using the satellite photography or satellite imagery, we could actually manage our disaster response so nicely that we have achieved this speed, and it is recognized by world. It is not that we are talking, it is recognized by Odisha has achieved this speed of zero casualty. Okay. Let us, because these are some of the projects I am associated with as a project leader. And today this project is going on. Odisha Paddy Validation Project. You know what you are doing? Odisha government, as you know, there is a paddy procurement system is there. You must be knowing that farmer is registering. There is a paddy procurement system where the farmer of Odisha, they will be registering their land at local the associations. They are there. Societies are there. They will go, they will register using that their plots, and they will tell that this much of land I am cultivating, and we will be selling paddy to the government. then that responsibility is given to Odisha Space Application Center in 2021 year, where they asked us to study that whether the farmer, those who are registering, they are cultivating their plots whether full or part, or they are not cultivating. We will be analyzing monthly, as you know, July the paddy plantation starts, and harvesting occurs maybe the December last of January. For every month, we take because this rainy season we take micro data, and during the off-cloud period we take optical remote sensing data, we analyze the sequential data. Or whatever this registration the plot, they provide the information to us. And what we do, we in Odisha Space Application Center, geo-reference, that means whatever the land map are there, revenue maps are there, that revenue maps are geo-reference. That means every plot is geo-tagged. So what we do, we put the satellite data and we overlay these plot areas and verify that whether every plot is having the paddy or not. Is it 100% cultivated or is it partly cultivated? So we create a database, every plot wise, that whether it is cultivated, yes, or it is not cultivated. We again developed a mobile app. Suppose there are also suppose there will be some 1%, suppose there will be some wrong interpretation. So that farmer will see that will, because of the science and technology, he may not lose that opportunity. What we have done, we have developed whatever nodes we have. Suppose some plots, something, their nodes are there. So we have asked the ground staff, under the collector, the agriculture department and the food supply and consumer welfare department. They are officers. They will go to the no areas. Yes area, they will get the benefit. They can sell the price. Though no area, they will go, they will take the photograph, they will ensure that okay, this is no, and if it is yes, because you see there are a lot of, we are processing the signals. After all, the signals may have some error, but due to that error, that farmers will not be deprived of selling the paddy. So again after that, then there is token is issued. The government will issue token, okay, this person can sell the paddy. So there this remote sensing technology used for the paddy procurement use. Another application, okay, that also have that Bhubaneswar Land Intelligence System. Here, which we call it. This application where you know government they have Bhubaneswar, they have the land. And every day the floating population they are setting up at this government lands, their work is developed. And once work is developed, they demand that okay, government when there is some plan you want to remove them, they will just we will not please give them some land actually. So in order to check that, government we are using the high resolution satellite data to monitor whether whatever basti is developed. Further to check that, we are using the satellite remote sensing. For Bhubaneswar, we are taking the high resolution something. You see, the area of something 60 centimeter by 60 centimeter is being done using that type of resolution data. Where that data we are using, and every month we are taking the data, and we are seeing the change in the land use. For any change in any pixel, you say 60 centimeter by 60 centimeter pixel, you say land, where we are monitoring that. We are using AI and ML. From pixel to pixel, what the change are getting. And whenever we are finding any change in any pixel, we are picking up that coordinate and we are creating a database. And again, we have developed a mobile app. We are sending that coordinate to the field from the BDA and the VIKSIT people. They are visiting the place and they are taking the picture. If there are some new buskins created or if there is some new fox around, and they are checking now at least whatever the government lands are there, that should not be occupied by any unknown persons. Okay, by that way, we are using the remote sensing to check the unauthorized access of government land. Application of UAV for mining sector. That also we are doing. You know, earlier How that is being done? Suppose a plain land is there which is identified for mining. Generally, it is a very small area. If we use satellite data, because satellite data has a revisit, something like after 10 days, after 14 days, it will take a revisit of that spot. If you use unmanned aerial vehicle or drone to take the picture of the area, drone takes the picture of the area of the virgin area where the mining has not happened. So it will take the virgin area. Then whenever mining will happen, so it will take again the picture and it will again compare because that is a stereo imagery concept. As you know, you have a stereo vision. You are blessed with a stereo vision. That means your left eye and right eye, you see an object and two images 100% overlap is being created, and you see the depth perception. The same science used by the camera. It takes the same area with the overlapping concept of forward overlapping 60% and lateral overlapping 20%. With that, it will create a stereo three-dimensional simulation will be created. That is created and a digital elevation model will be created. With that, if you differentiate two digital elevation model, you will find the volume. What is the volume of the actually minerals extracted? So now the days are gone. Somebody will measure the heap of the area or reaching or rectangular. It will take a transaction and measurement find out the volume. That is now is over. We are using now the UAV technology. Looks like it's involved. The private companies are also there, which are actually the mining companies. They are using their services, and we are validating because it should be more precise. What the volume every month that is getting extracted from every mine. So government should have a regulation to it, and they should know because accordingly they will pay the tax. So now the application of the UAV for mining sector it is regulatory. One has to do it is must. Otherwise, the manual measurement nobody will accept. Okay. So this is the science where you can use the UAV to determine the volume, to determine the land use, land cover of the change, whatever the change is occurring that will do. So UAV remote sensing is also required. What is the spatial data infrastructure OSD? Also, I was the project leader of this project where we are creating VIKSIT, which is actually developed from 1984. Since then, it is generating data. It is procuring the satellite image. Then what we are using government fund. Once you are using government fund, that data should be available freely to everyone because you have used government fund. So, taking that concept, Government of India, they have National Spatial Data Infrastructure, NSDI. So, if you actually Google it, Odisha Spatial Data Infrastructure, you can use your own email ID to register, and you can get the data whatever is being generated. That means land cover, road, river, ponds, whatever data OSAC has generated, they have stored it in a database server, and they can, as a student, you can take the data in the format of course, in a OGC format. You have to take either you have to take WMS or WFS, web feature service, or you can take a web map service. So you have to know about that. So using that service, you can use the data, whatever past data is there about your area, you can download that and you can use for your study. So that is information for you. Okay. Also, you can use Bhuban, ISRO data also. They have a site called Bhuban, site BHUBA and Bhuban. They have a site called Vedas, VEDAS, Vedas. So there also you can log in. You can get the data of some country data, wherever country. Your remote sensing data you can get free. You can download and for researchers that is required. The next decade introduced complex orbital assemblies and human spaceflight, where now we are planning in 2026 India's flagship human spacecraft preparation, engineering a life support capsule and a crew escape system for low orbit Earth, where the scientists will be there to study, like USSR, they have done. So we are planning to do it in 2026. SpaceX, space docking experiment, providing the autonomous rendezvous and docking capability is absolutely required for assembling future space stations. That we are doing. Nicer already we have done. In collaboration with NASA. India will establish a permanent human presence in orbit and on the moon. So Chandrayaan 4 we are planning. Bharatiya Antariksh Station we are planning. Sukrayan and Mars Orbiter 2 we are planning. Human lunar mission we are planning. These are the future plans. The orbital economy requires massive influx of multidisciplinary minds. And minds, that minds, you are the minds. Because you know, the peoples they are growing, they will be retiring, and the new people they will be taking the place. So you being at studying physics, mathematics, chemistry, and geology, you are the people those who will be filling this gap. Okay. There was also some evening law, space law, computer science, data science, cyber security, mechanical engineering, GIS. These are part, no? Message to students, so that you should be always curious. You should ask questions, explore ideas, whatever ideas coming, you should explore ideas and never stop learning. So that is the be curious, then your fundamentals. Whatever now you are studying, you should say that no. Whatever you are studying, you should say that you will be strong on that field. You should be strong in mathematics, physics, computer science. So once you be strong in your study, then you can actually aspire for be curious and you can achieve also at that stage. Learn modern technologies. You should have the programming ability. Nowadays you see, the student may be at you see at ODR or at you should have the computer knowledge also. Be at some knowledge. You should learn at least some easy something Python, something Google coding. It is very easy. If you learn, spend time, something 15 days, 30 days, you will be strong in computer science. Okay. Think like a researcher. Experiment, innovate, and solve the real world problems. Work collaboratively. Experiment, work collaboratively means great space mission are built by multidisciplinary teams. Always, whenever that is you associate with others, you share your thoughts, you ask your friend that what do you think about it? This is what I think. So this is collaboration. He will give some idea. You think about your problem with your professors. Say that, sir, I have this thought. How can I achieve it? Then these are called collaborations. Okay. Work collaboratively, use technology for society. So whatever you do, develop solutions for agriculture, disaster management, climate change, healthcare, and sustainable development. Okay. What are the career opportunities in the space sector? You can be a space scientist, conduct research on planets, galaxies, and other universe work on research that expand our knowledge of space. Aerospace engineer, you can be aerospace engineer. You can design, develop, and test spacecraft, launch vehicles, and propulsion systems that make space missions possible. You can be a satellite system engineer also. You can be AI and machine learning specialist. If you are computer science, you can do that. Even if you are digital, you can do also. A mathematician also can do it. Data scientist, you can be a data scientist also. GIS and remote sensing expert. So you can be a GIS and remote sensing expert also. Robotics and automation engineer, space communication engineer, you can be a cyber security specialist, you can be a space entrepreneur and a startup founder. You can have your own startup. So, lastly, I can tell art is the cradle of humanity, but humanity cannot stay in the cradle forever. This is the statement of Constantine Triloskovich, where Indian journey from the humble beginnings of Arjavata to the staggering ambition of Gaganayan, we have evolved from a nation dreaming of space to a superpower living in space. The cosmos awaits your contribution. Thanks a lot for your attention. I will be thankful to Honorable Vice Chairman sir, and all the professors giving me this opportunity to keep my whatever small things I know, to keep my things before you. And I will leave you three things before my conclusion. Wherever you are, you try to concentrate on your study. Whatever subject you are there, try to gain the knowledge there. And then you should dream big. You should not think that I am a student of Odia or I am a student of geography or I am a student. You always dream big. And once you dream, you will try to achieve your dream somehow. If you don't dream, always you dream something to achieve something and then do something for the society. Once you achieve something, please try to deliver something for the society. With this, I conclude. Thanking again.
Thank you, sir, for your enlightening, informative, and motivating address. Your words truly encourage young minds to pursue scientific excellence. Now, I request our Vice Chancellor, sir, for his address.
Speaker Pramod Kumar Parida, Chairman PG Council, Professor Santosh Kumar Gorala, faculty from Department of Physics and other departments, students, research scholars, and friends. I'm very happy that this National Space Day is celebrated by Department of Physics to remind us to cherish for the Chandrayaan. So I am delighted to hear Srimati Parida how we are progressing in space research, how space research helps us, starting from land management to water management and what. I think students are immensely benefited out of this talk. With that request, I thank Parida for this beautiful talk. I thank all of you because this is one occasion when I found that the house is full. At least if 70% of you have learned something, maybe that is more than 200. And for those 200, I expected clap.
Thank you, sir, for your inspiring and insightful remarks. As we approach the conclusion of today's celebration, I invite Mr. Hemant Kushal Nayak, sir, to deliver the formal vote of thanks.
Most esteemed Vice Chancellor, Sri Santosh Kumar Tripadi, sir, respected today's Chief Speaker, Resource Person, Mr. Pramod Kumar Parida, sir, respected Chairman of Council and HOD in Physics, Professor Santosh Kumar Gorala, sir, respected Vivek sir, Rajiv sir, Samar sir, Jyot sir, respected faculty member from different department, research scholar, student, media person. On behalf of Department of Physics and on behalf, I would like to thank all the students for being here present, being attend this seminar attentively. Thank you all the listeners. First and foremost, I would like to thank our Vice Chancellor sir, Sri Santosh Kumar Tripadi sir, for accept our invitation, give a suggestion and help to make this event successful. Thank you, sir. I'd like to thank today's resource person, Mr. Pramod Kumar Parida, sir, accept the invitation and give a beautiful talk to the audience on this National Space Day. Thank you, sir. Along with, I'd like to thank the power of women, Madam Parida, Madam, being with us. Thank you, Madam. I'd like to thank Chairman of Council for supporting, motivating to organize this National Space Day. Thank you, sir. I'd like to thank Vivek sir, Raj sir, Ramon sir, Subhash sir, and all the faculty members of different departments for being attending this Space Day. Thank you, and thank you all. Have a good day.